Okay, what we're looking at right now is a Heathkit RF-1 signal generator. It was the predecessor to the IG-102 and came out in 1960 and was replaced by the 102 in 63. So just ahead of the 102. This particular unit is in excellent condition. Cabinet is in has a nice glossy finish to it. Everything is still legible. There's no scratches on the surface of any size or what would you call it? Complaint anyway. There is a tiny chip right here you can see, but it's in extremely good shape. Top of the case, the handle's in good shape. Sides. And the back. I have replaced the original button style microphone type connectors that were on there with the newer BNC model, and you're then able to use BNC connectors which are available on eBay for just a few dollars a piece instead of paying the vintage price for the harder to get items. And so what we're going to do right now is to give you a view as to the performance capability of this RF-1. As you can see on the oscilloscope, we're right now showing the lowest frequency on the lowest scale, something in the vicinity of about this would be about 100 kilocycles, maybe a little bit less, maybe 95, something like that. It goes up to 320 on band A. So I want you to pay attention to the waveform that's on the oscilloscope as I sweep through the frequencies. Look for any abnormalities or anything that you would find objectionable in your use for alignment or any kind of filter work or whatever it is you're doing with your signal generator. Okay. All right, I'm going to start sweeping. Here we go. I'm up to about mid-band right about now, and then sweeping towards the 320 kilocycle output. Let's shrink this down a little bit so you can see it. Alright, and then we're going to go to band B. Band B sweeps from 310 kilocycles to about 1100, 1.1 megacycles. So right now we are below 310, and then we're sweeping forward. Alright, we're at the end of the band. Going to band C. Take her back down again. 1 megacycle to 3.2 megacycles. Take this up a little bit, so there we go. 1 megacycle to 3.2. I'm sweeping up. We're about mid-band right about now. Efficiency's going up. We're getting off the screen a little bit, so I'm going to turn the attenuator down a little just to bring the signal back onto the screen. There we go. And then 3.1 to 11 megacycles. Okay. Sweeping forward. Getting very efficient again. The upper end of the band. Alright. Let's go ahead and 10 megacycles to 32 megacycles. Make sure we can see this thing. There we go. Take her from here. Here's 10, sweeping towards 32. Oops, we're off the screen again. Let's turn it down. Okay. Let's do that once more. Okay, we're at the low end, 10, sweeping to 32. There we go. And then finally we're on band F. This is 32 to 110 megacycles. And in order to see it all, I'm going to expand my display here. Let's get ourselves back down to the low end. And there we go. Alright, we're at 32, sweeping to 110. We are right now approaching, well, that's the 110 right there. We actually kind of peaked out a little bit at 110. I'm turning the attenuator down a little. There we go. So we had a nice clean waveform through all of the ranges. We tracked well. We're going to go ahead and take a look and spot check some of the frequencies at different points on the vernier just to see how accurate the vernier is. Not that I actually ever expect a whole great deal of accuracy out of a vernier. If I'm within 3 to 5%, I'm usually amazed, but often these things are within an amazing, maybe 1%, something like that. Let's take a look though. I'll hook it up and we will check it. Okay, I have the vernier right now set directly on 32, and what we see on the counter is 31.75. Let's go ahead and take this up to about mid-band. I'm going to call it, we'll say 60. That looks to be 60 right on the nose there. And what I'm seeing on the frequency counter is 60.3. So that's very good. Let's take her all the way up. 110 megacycles. That would be 110 right there. And I am reading 109.85, so 109.9. So on this particular range, this is band F, we are very accurate on the vernier. Let's go to band E. On band E, I would be adjusting for 32 right here. And what I am seeing on the counter is 31.3. Alright, I'm going to take her down to about mid-scale. I'd call that about 1.7. That would be 17 megacycles, right about there. And I am seeing 16.99 or 17, so it's right on the nose. Let's take her down to 10. 10 would be right about there. And I am getting 9.987, so 10 right on the nose. Band D. Band D, I go to 3. That'd be 3.1 megacycles on D, right about there. And I am reading 3.1 megacycles. 3,122 kilocycles, so 3.1 megacycles. Let's take her up to about mid-band on this range, and I'm going to call it 55. 55 is right about there. And I am reading 5.5. I said 55, and I meant 5.5. It's 5.5 megacycles. 55 on the band, on the scale, on the vernier. 5.5 is what we got. Take her on up to 11. And that should be 11 there. And I got 10.85. 10.9. That's very close to 11. Doing well. Band C. We are 3.2 at this end, and that would be 3.2 there. right on the end. And I am reading 31.4. 3.14. So 3.1, and I expected 3.2. So we're a little bit off by 0.1 megacycle. I'm going to take her down to mid-band, and I'm going to call that 1.7 megacycles, and I am getting 1693 kilocycles, or 1.7 thereabouts. And take this down to 1 megacycle. One would be right about there, and I am reading 997 kilocycles. So we are 3 kilocycles out of 1,000 away from 1 meg. So we're very good. B, band B, we go from 310 kilocycles to 1.1 megacycles. Band B is in the center here, so I go to 3.1. That would be 310 kilocycles. I am reading 311.9, so 312. We expected 310, we got 312, so we're 2 kilocycles out of 300 off. Not bad. Mid-band, I'm going to call 550 kilocycles, and I am getting 552. And then high band, where I should get 1.1. There's 1.1. And I am reading 1.085, so 1.09 instead of 1.1. How's that? Not bad. Band A, we go from 100 kilocycles to 320 kilocycles. Band A is on the other end here, so let's pick 320. That would be 320 right there. And I'm getting 318 kilocycles. 2 kilocycles out of 320 off. Take her down to mid-band. I'm going to call that 170 kilocycles. And it reads 170.0, so it's right on the nose. And then taking it down to the bottom of band A, which would be 100 kilocycles, I am reading 100.19, so 100.2. How's that? Out of 100. That's pretty darn good. So this thing is tracking amazingly well for a vernier scale. It's tuned very well. Okay, so got a nice clean waveform over all the bands. We got a very tight selection of frequency using the vernier. Let's take a look at the internal modulation, which means I got to go back to the scope. Not a big deal. All right, we're back on the scope, and all right, that's with none. And that's modulated. Okay. Okay. Modulated. Not modulated. Modulated. Not modulated. So you can see it. And that would pretty much be the end of it. Let's take a look at the modulation signal. See what we got. Here we're looking at the modulated signal. I can turn it down using the audio frequency output. Turn it up again. No signal, audio signal. It's about 400 hertz, something like that. So everything is working. We have audio output, we have RF output, we covered the bands, and our vernier is accurate. So hey, it's a good unit. It looks nice. It's a little bit older, so I am selling it just slightly cheaper than the 102. But it will come with a manual, which To be honest, there is no difference other than the case between this unit and the 102. The 102 has a little more modern case to it. The circuitry is identical, but I do have the specific book made for this RF1 generator, and that will come with the unit, along with a nice set of leads, which will look like this. Brand new set of gator clip leads, BNC end, coax type cable. It's a nice set of leads, so it'll come with that, the manual, and the unit. So thank you for listening, and good bidding.